This is the Solving Trig Functions tutorial. There are many different ways to solve trig functions, and I'm going to show you a half a dozen different ways in this tutorial. The first and easiest way I'm going to show you is using the calculator method. So in this problem, you're asked to solve for cosine theta equals 0.58. So we're solving for theta, and we've been given an area in which theta occurs. Theta occurs between 0 and 2 pi radians, so basically anywhere within the unit circle. Now I'll go ahead and bring in the unit circle to help us with this problem a little bit. Now, if you know that cosine theta is equal to 0.58, you can simply take the inverse cosine of both sides of the equation. So we're going to take cosine inverse of 0.58. And when we do that, we're going to get just theta because we've taken the inverse of this side here on the left. So if you were to just put that directly into your calculator, and you can just hit second cosine and 0.58, you'd get 0.95 as an answer for theta. Now right now, our calculator mode is in radians, so we're dealing with our answer here in radians. So 0.95 in radians is going to occur right about here on our unit circle. Notice that pi radians is over here at 180 degrees, and pi is roughly 3.14. So pi over 2 is here at 90 degrees, so that's half of 3.14. And 60 degrees is pi over 3, so 3.14 over 3. And 3.14 divided by 3 is just slightly more than 1. And our answer is slightly less than 1, so we're going to be a little bit less than pi over 3 radians. Alright, so according to your calculator, that's the answer for theta. However, whenever you use the calculator method, you have to check for other solutions. And here's how you do that. If you recall, this is quadrant 1 on the unit circle, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And you may remember our acronym, all students take calculus. So with that acronym, we're suggesting that in quadrant 1, all of your trig functions are positive. In quadrant 2, only your sine function is positive. In quadrant 3, only your tangent function is positive. And in quadrant 4, only your cosine function is positive. Now, we know that cosine theta has a positive value. And it has a positive value only here in quadrant 1, where all trig functions are positive, and here in quadrant 4, where cosine is positive. So to solve for the remaining value of cosine that will work, or the remaining value of theta that will work for this problem, what you want to do is you want to take 2 pi, this amount of radians here, and you want to subtract our answer of radians. So you want to take 2 pi and subtract 0.95. When you do that, you get an answer of roughly 5.3 radians. So our second answer for theta is going to be 5.3 radians. Now you may be wondering why we took 2 pi and subtracted our original answer that was given to us by the calculator. Let me explain a little bit as to why we do that. Your answer that you're checking for is always in respect to the reference angle, and the reference angle is always in respect to the x-axis. So, if you're given a value of cosine and you know that it's in this quadrant 1, what you want to do is move from the axis to the other answer of your cosine that's positive, because you know your answer in this case was positive, you were told it was. And if you're moving from the x-axis here on the right, that value has a value of either 0 or 2 pi. Since we want it to be positive, we want to subtract from 2 pi, because if you were to subtract 0.95 from 0, you'd get a negative 0.95. And we know that our answer is positive, so we decide to subtract from 2 pi. However, imagine if this problem were the sine of theta is equal to 0.58. If the sine of theta were equal to 0.58, you know that one of your answers would be here, because all of our trig functions are positive in this quadrant, and in this case we were given a positive sine trig function. And you know that your second answer would be here in quadrant 2, because in quadrant 2, your sine values are positive. Now, you want to measure from the x-axis again to find your second value. So in this case, you would have taken your x-axis value, which is pi, and you would have subtracted the answer that you got from taking sine theta is equal to 0.58. Now you would have subtracted because you want your answer to be in this direction so that it arrives in this quadrant right here. And whenever you go clockwise on the unit circle, you're going in the negative direction, so you're subtracting from pi in this case. So notice your answer is always in relation, your second answer that you're looking for is in relation to the value of your x-axis. So, if we had been given a trig function of tangent theta is equal to 0.58, you know that your first answer would have been here in quadrant 1 because, again, all trig functions are positive in quadrant 1, and your second answer that you would have had to look for would have been here in quadrant 3. Now, your calculator wouldn't have given you that second answer in quadrant 3, so the way to find it is to take pi, again, start from the x-axis, and go this direction because you want to be in this quadrant. You don't want to go up because you'll be in quadrant 2. So you're going down to make sure that you stay in quadrant 3. And when you go down, you're going counterclockwise, which means you're going to be positive. So you're going to add whatever value you got from tangent theta is equal to 0.58 in your calculator. You're going to add that value of radians to pi. And that's going to give you your second answer that your calculator won't return for you. Alright, so that's the calculator method for solving trig functions. Now let's take a look at the method for solving linear trig functions. So for this, I'd like you to solve this equation. 4 cosine squared theta is equal to 1, and theta is located between 0 and 2 pi. So I'm going to go ahead and bring in a unit circle again, because we're going to use that a little bit later in this problem. And when you're solving a trig equation linearly, you just want to solve it like you do a regular problem. So we have 4 times the cosine squared theta is equal to 1. So I'm going to divide by 4 on both sides of the equation to begin with. When I do, the 4's are going to cancel on the left, and we're going to have cosine squared theta is equal to 1/4. Now remember, having cosine squared theta is very much like having cosine theta squared. You can think of it that way if you'd like. And if you think of it that way, to get rid of that square, what you want to do is take the square root. And what we do to one side of the problem, we have to do to the other, so I'm going to take the square root of both. On the left side of the problem, the square root is going to cancel out the square, and we're going to have cosine theta remaining. On the right-hand side, we have the square root of 1/4. And you can think of that as the square root of 1 over the square root of 4. Well, you know that the square root of 1 is just 1, and the square root of 4 is 2. So, now we have the cosine theta is equal to 1/2. Now you want to check your unit circle to see what theta would be if its cosine were equal to 1/2. And remember, cosine is the x value of each of these coordinate points around the unit circle. So we want to look for 1/2. Well, here's our first answer, which occurs at 60 degrees. So theta is equal to 60 degrees is one possible answer. Or you could express that in radians and say theta is equal to pi over 3 radians, which is your answer here. Now you want to look for anywhere else where your cosine value is going to be a positive 1/2. And that occurs again here at 300 degrees. So your second answer is going to be 300 degrees. Or, if you'd like it in radians, it's going to be 5 pi over 3. And remember, we just moved down from the x-axis. That same distance we moved up 60 degrees, we just moved down 60 degrees from there. Because when you want to find your second value of cosine, you move down from 2 pi radians, or 360 degrees, in this direction. Alright, so that's how you would solve linear trig equations. You just consider them to be like a regular algebra problem and work through them. Now let's move on to doing a little bit more work in finding all the solutions to a trig function. Alright, so this work is going to be reminiscent from the calculator method. I'd like you to solve this equation. Sine of theta is equal to root 2 over 2. However, I don't want you to use your calculator. So the way to do this without your calculator is to take a look at your unit circle. And in your unit circle, sine of theta is going to be the y-coordinate of each of these points. So if you're looking for sine of theta is equal to root 2 over 2, you're looking for anywhere in which your y-coordinate is equal to root 2 over 2. The first place that you might find that occurring is at 45 degrees, right here. And the second place is going to be over here at 135 degrees. You could also think of each of these answers in radians. So, for this problem, your answers for theta are either 45 degrees, which is pi over 4 radians, or it could be 135 degrees, which is 3 pi over 4 radians. Now remember, your acronym here, all students take calculus. Obviously your sine value is going to be positive here in quadrant 1 because all trig functions are positive in quadrant 1. However, you knew to look in quadrant 2 for your second value for sine theta here because your theta was positive, and that's the only other quadrant in which your sine values are positive. So even if you didn't have all these nice convenient values present on your unit circle, what you could have done was just solved for that first value, or known that it was root 2 over 2. You could have solved for the number of radians there, pi over 4, and then you could have gone from your reference angle, which was the x-axis here at pi, and you could have subtracted that pi over 4 because you want to go in this direction to remain in quadrant 2. And if you had subtracted pi over 4 from pi here, you would have gotten 3 pi over 4, and that would have been your second answer here. So that's a way that you can find all the solutions without a calculator and only your unit circle. Now let's go ahead to determining whether or not a number is a solution for a given problem. So for this work, I'd like to determine if theta is equal to 2 pi over 3 is a solution to the equation cosine theta is equal to negative 1/2. And after that, we could check theta is equal to 5 pi over 6. So what we're going to be doing for this problem is we're going to be plugging this value of theta, 2 pi over 3, into theta here, and determining whether or not that actually works as a solution to this equation. So to help us out, I'm going to bring in our unit circle again. And what we want to do is check whether or not cosine of theta, and we're using this value for theta, so cosine of 2 pi over 3 is equal to negative 1/2. So what you want to do is find this value in radians around your unit circle. So if you go around the unit circle, you arrive at 2 pi over 3 eventually, which is equivalent to 120 degrees. Now the question is whether or not the cosine of 2 pi over 3, so the x value, is equal to negative 1/2. And if you check, it is equal to negative 1/2. So for the first part of this problem, you would say that yes, 2 pi over 3 is a solution to the equation cosine theta is equal to negative 1/2. Now the second part of the problem asks us to check whether or not theta is equal to 5 pi over 6 is a solution to the equation as well. So we'd write it out again, cosine of theta, and now we're using 5 pi over 6 for our theta, is equal to negative 1/2. So we want to travel around the unit circle until we hit 5 pi over 6 radians. Then we want to check the cosine value, so the x-coordinate of that value, to see if it's negative 1/2. And in this case, it's negative root 3 over 2, which is not negative 1/2. So this is not a solution to this equation. Cosine theta is equal to negative 1/2. So by now you also know that there's going to be a second answer to this equation. You weren't asked to find it, but if you were asked to find it, you'd know how. You know that cosine of 2 pi over 3 is equal to negative 1/2. So this radian value, 2 pi over 3, does return a value of negative 1/2. So to find the other negative 1/2 value, since we're dealing with cosine and we can use our acronym, all students take calculus, we know that we want to start from this x-axis here, and we want to go down in this direction. We want to go down the same distance or number of radians that we traveled for that first problem to arrive at 2 pi over 3. So we want to go down 2 pi over 3 radians from 2 pi. And when you subtract 2 pi over 3 radians from 2 pi, you end up at 4 pi over 3 radians. That would give you the other negative 1/2 value for this cosine theta trig function. And remember, we subtracted from 2 pi because we were going clockwise on the unit circle. Now I want to show you how to solve a trig function in the quadratic form. So imagine that you were given the equation sine squared theta minus sine theta is equal to 2, and you were told that the value of theta occurs between 0 and 2 pi. You could solve this equation in its quadratic form, so let me show you how you'd go about doing that. So we have sine squared theta minus sine theta is equal to 2. And remember, when you're solving a quadratic equation, you want to set everything equal to 0. So I'm going to subtract 2 from both sides of the equation here. So we're going to have sine squared theta minus sine theta minus 2 is equal to 0. Now it still may look a little confusing, but what if I were to take every sine theta here and just abbreviate it as x for the moment? So we have sine theta squared, so x squared, minus sine theta, x, because every sine theta we're turning into x, minus 2 equals 0. Well, this might look a little bit more familiar to you and a little bit easier to work with. So you just want to go ahead and factor this, and when you factor that, it's going to look like this. X minus 2 times x plus 1. Now hopefully by now you're really skilled at factoring. If you're not, I suggest you go back and watch some of the tutorial videos on factoring and do some of the example problems that we've got to build up your skill a little bit at it. So now that we converted every sine theta into x, so now I'm going to convert back our x's to sine theta. So this really looks like sine theta minus 2 times sine theta plus 1 is equal to 0. And remember, when solving a quadratic, we want to set each of these parenthesis sets equal to 0. So over here on the left, I'm going to do sine theta minus 2 is equal to 0. So we want to add that 2 to both sides of the equation. And we find that sine theta is equal to 2. Now you could take your calculator and do the inverse sine of both sides of the equation here. When you do that, you're going to be taking the inverse sine of 2 to solve for theta. And what you get is a bad domain or a domain error in your calculator, which means that this answer, this solution for the problem, isn't going to work. But we should check the other solution. Sine theta plus 1 is equal to 0. So that's this guy in parentheses down here. So again, we're going to subtract 1 from both sides of the equation. So we'll have sine theta is equal to negative 1. Then we'll take the inverse sine of both sides. So we get the inverse sine of negative 1 is equal to theta. And when you do that in your calculator, you find that theta has a value of roughly negative 1.57. So for this problem, this is the only potential answer for theta that works. That's going to occur occasionally when solving trig functions in the quadratic form, that you only get one answer that works and one that doesn't. So don't be too worried if that happens for you. So now I'm going to teach you how to solve trig functions using an identity. Let's take a look at this guy right here. You already know that I've asked you to solve using an identity, so you're going to be looking for identities hidden somewhere within this problem. So look at this guy right here, cosine squared x. You may remember your Pythagorean identity that the sine squared x plus cosine squared x is equal to 1. So if I were to subtract sine squared x from both sides of this equation, we'd get cosine squared x is equal to 1 minus sine squared x. So I'm going to begin by plugging that in for cosine squared x. So we've got 2 times 1 minus sine squared x plus 3 sine x minus 3 is equal to 0. Now I'll go ahead and distribute that 2 and simplify a little bit. So 2 times 1 is 2, and 2 times a negative sine squared x is a negative 2 sine squared x plus 3 sine x minus 3 is equal to 0. I'll go ahead and combine our like terms now, so we'll add that 2 out front to the negative 3 and back, and we'll get negative 2 sine squared x plus 3 sine x minus 1 is equal to 0. Now I'm just going to multiply both sides by a negative 1 so I can get rid of some of these negatives. So everything here by a negative 1, and then we'll multiply 0 by a negative 1. So on the left-hand side, we're going to switch the sign of everything. So we now have 2 times sine squared x minus 3 sine x plus 1 is equal to 0 times negative 1, which is still 0. Now this is starting to look a little like a quadratic. If we just changed all our sine x's to just x, it would look like 2 times x squared minus 3 times x plus 1 is equal to 0. So notice anywhere I had a sine x, I just changed it to x to make it a little bit more easy to deal with. When we do that, we could then factor. And if we factored that, it's going to look like this. 2x minus 1 times x minus 1 is equal to 0. And now you can go back and change your x's back to what they were, which was a sine x. So that's going to look like 2 times sine x minus 1 times sine x minus 1 is equal to 0. Now you want to solve each of those, so you set them each equal to 0. So we have 2 sine x minus 1 is equal to 0. So I'm going to add the 1 over, add the 1. So we have 2 times sine of x is equal to 1. Then we'll divide by the 2 here, and we get sine of x is equal to 1/2 as one of our answers. And this guy we'll do over on the right. So we have the sine of x minus 1 is equal to 0. So we'll add 1 to both sides, and we get the sine of x is equal to 1 as another one of our answers. Now, since we're solving for x, you want to check those answers on a unit circle. And when you look for a y value of 1/2, you'll find that that arrives at a couple locations. So x is going to be equal to pi over 6 radians and 5 pi over 6 radians. And then if you look for a y value of 1, you'll find that that's 90 degrees straight up, and you'll get x is equal to pi over 2. So those are going to be the 3 values of x for this problem. Now I would say that solving these trig functions using an identity is oftentimes the most difficult way to do it, but it's a way that you should know because sometimes it's really the only way that you can solve one. I hope you learned something using these different ways to solve for trig functions.